Welcome, ladies and gentlemen, to the free response question review. In today's episode, we will be discussing the 2006 version B AP Calculus BC exam, question number 4. This question also made a cameo appearance on the Calculus AB exam of that same year. The question reads, the rate in calories per minute at which a person using an exercise machine burns calories is modeled by the function f. In the figure above, f of t equals this polynomial between 0 and 4 and is a piecewise linear from 4 to 24. So let's start answering some questions here. Question A, it says find f prime of 22, indicate units of measure. So f prime of 22. Well, if I go to 22, that's going to be about right here on the graph. So luckily it's linear, so I can go ahead and call him 3 minus 15 over 24 minus 20. And again, if I was doing this on the AP exam, I would go and leave him as is. But if I wanted to simplify for purposes of making it simple, it ends up becoming negative 3 calories per minute squared. Since the graph is already measured in calories per minute, then when we take the derivative, it would be calories per minute squared. Please pay attention to the minute squared. Part B is really the hardest question on here. And so it says, for the time interval 0 to 24, at what time is f increasing at its greatest rate? So the word increasing at its greatest rate is really an important clue in this problem. It says show the reasoning that supports your answer. When I see the word increasing, my first thought is to go to f prime. Because the first derivative will tell you when a graph is increasing. But when I see the word greatest, I also think about f prime. So if I'm going to take the first derivative to find out where f is increasing, and I want to find out increasing greatest, then I want to take the first derivative of my first derivative. In other words, I'm going to be taking the second derivative of this graph at some point in B. Now, couple things. One, before I even do any calculus, there are a couple of places on this graph that are automatically disqualified. I'm going to go and write those down. I know that from 4 to 12, union 20 to 24 are disqualified. And that's because at those moments in time, f prime is either equal to 0 or it's negative. So I'm going to go and write that out because I can't do that in math type here. F prime is less than or equal to 0 at those points in time. So I don't even need to worry about those because I want to look at calories burning, the increasing parts of the function. Oh, and I totally forgot an interval there. I meant also 16 to 20. Totally forgot about that guy also. So really, I only need to look at the increasing portions of the graph. So I'm only going to consider from 0 to 4 and from 12 to 16. So here's what I'm going to do. I'm going to go ahead and take the second derivative of this guy, but the 12 to 16, I don't need to worry about taking the second derivative because his increasing is linear. His increasing is at a constant rate. So why don't I go and just figure out what that is? Actually, that's going to be easier. So I'll go ahead and find out what that is. That's going to be, according to the graph, 15 minus 9 over 16 minus 12, which is going to get me 6 over 4. So what I want to know if my increasing rate on the 0 to 4 is smaller or larger than 6 over 4. So that's what I'm going to figure out here. So let's find out what f of t is. Well, f prime of t is going to be negative 3/4 t squared plus 3t. But remember, that just tells me increasing. I want to know increasing fastest. So that's going to be f double prime of t, giving me negative 3 over 2t plus 3. I'll set them equal to 0 to find out when that happens. And if I look really hard, I'll find out that this happens at t equals 2. Now, how does that help me? Well, one, in a sign chart, I know that at 2, this guy is linear, so he'll go plus minus, linear negative. But now I want to find out how many calories are actually being burned, or the rate of the calories being burned at time equals 2. So what I'm going to do is I'm going to find out what f prime of 2 is. Well, that's going to be negative 3 over 4 times 2 squared plus 3 times 2. Those are going to go away, give me negative 3 plus 6. That gives me 3. So my f prime of 2 is going to go in here. So what this is this is the rate of burn, and this is the rate of burn. And I'm going to compare my rates of burns. Did I put 2 right there? Ridiculous. 3. And which one's bigger? It's this guy. So what we can say is I'm going to type this out. I'm going to say the rate of calorie burn is greatest at t equals 2. Easily the hardest question on this FRQ here. So if you need a second, go and copy that down, ponder it. If you still have questions, put them in the comments section, but I'm going to be back with question C in just a second. Clean up the board. Part C says find the total number of calories burned over the time interval 6 to 18 minutes. Okay, this graph is really, really, really odd looking, and to find out all of this is going to be really, really hard. I mean, C is easily the hardest question in this FRQ. So what I'm going to do is I'm going to actually just write it out first. I know it's the integral from 6 to 18 of f of t dt. Luckily, it's just going to be a bunch of linear stuff. I don't need to integrate the actual wavy function, which is good. So I'm going to go and just draw down a thing here, 6. And notice how they gave me the limits of integration not at clean places. I don't like how they did that, but that's okay. I can't really complain. So I'm going to take that rectangle from 6 to 12. So I'm going to do that first. So what is this? This is a rectangle from 6 to 12. I have a base of 6 and a height of 9. And then I'm going to do another color here. And then I'm going to go ahead and do this. This right here is going to go from 12 to 16. So that's a trapezoid right there. So 12 to 16 with my height being 4. So that means that I'm going to get 1/2 height, which is 4. And then base 1 is going to be, looks like 9. And then base 2 is going to be 15. And then my last color here, I'm going to go ahead and do all the way to 18 right here. This little slither of a rectangle right there. And that's going to be, looks like a base of 2 with a height of 15. So again, a lot of wonky, weird shapes, easily, just really hard problem right here. And again, at this point, you can go ahead and leave the problem like this. At this point, the problem kind of falls apart. But if you really wanted to simplify this thing, and you might need to for part D, it's going to be 132. So again, the hard part about this was actually separating the shapes. It made it really, really, unnecessarily difficult. But as long as you can keep your shapes straight, then you should be okay. Okay, let's go and move on to part D. All right. D reads, the setting on the machine is now changed so that the person burns f of t plus c calories per minute. For this setting, find C so that an average of 15 calories per minute is burned during the time interval 6 to 18. Okay, a lot of words in this problem here. They throw in this f of t plus c. I would definitely say that D is actually it's easily the hardest problem on number 46 here. So let's go and take a look at it. We know that it's f of t plus c. We know that this is the new function of our machine right here. Well, I know I'm going to try and find out the total number of calories burned from this new setting here. I know it's going to be 6 to 18. But what makes this problem accessible is the word average. And I know that average means 1 over b minus a, which is 1 over 18 minus 6. And I know that that's going to be dt. Sorry. And what I want is I want my average. Remember, this expression here is giving me the average calorie burn. And I want that average calorie burn to be 15 calories per minute. So, how do I clean up this problem? Well, I call him 1 over 12, integral from 6 to 18, and I'll go and say f of t plus c dt equals 15. To make things easier, I'm going to go ahead and multiply both sides by 12. And what I get is the integral from 6 to 18. And I'm actually going to go and split up my integral, because at the end of the day, I'm going to solve for c anyway. And that's going to equal 180. Now, luckily, we already have this answer. This dude is 132. We saw that in part C. Now, this guy here, well, remember, he's just a rectangle with a height of c and a base of 12. So that's 12c equals 180. And from here, I just go ahead and solve. So I get 12c equals 48, divide by 12, and c equals 4. And I think that would wrap it up for this exercise problem. Hopefully it wasn't super confusing. If you have any questions, go and leave them in the comments section, and I'll be back in the next episode.